Today we're going to be talking about Xamarin Forms, and if you've never heard of Xamarin Forms, just a real quick definition is it's a framework provided by Microsoft that allows you to use .NET tools and techniques that you already know to build cross-platform mobile applications. Cross-platform meaning they run on Android, iOS, and technically Windows too, like the UWP stuff that ran on Windows Phone, although I don't think most people like to talk about that these days because it's very dead. But you can use it to build, I think you can still use it to build desktop apps for Windows using the UWP stuff. But we're going to mainly be just talking about the iOS and Android portion of it. And before we can talk really about Xamarin Forms itself, so let me pull up some notes here, we need to talk a little bit about the frameworks that it's built on top of. So before Xamarin Forms, I'm not really totally sure the history on how everything came about, but at one point there was just Xamarin, which is essentially a framework. There was two versions of Xamarin. There was Xamarin Android and Xamarin iOS, and both of those frameworks are essentially C# wrappers around the native SDKs for iOS and Android. So you could go to Visual Studio and start a Xamarin Android project where you are essentially building a native Android application the same way you would with tools like Java, with the main difference being you have access to all of the .NET libraries and you use C# instead of Java. And then there's also the same thing for the iOS side of things where you can use C# instead of Objective-C. Now, when you're building a Xamarin Android and a Xamarin iOS application, you still have to do all of the work UI-wise that you would have to do if you were doing it natively, right? Because it is truly a native project, just with the language kind of swapped out. So that means in an Android project, you're using Android's XML language to build out your UI, and then you're just using C# to kind of do the code behind, if you will. On Android, those code behind files are called activities, to hook up the UI to data and to handle events on the platform and all that kind of stuff. And then the same thing on iOS. You would use storyboards is the kind of way of building UI in an iOS application. And you still have to, once again, you have to do the UI completely separate. Now there is instances where you can maybe share code between a Xamarin iOS and a Xamarin Android project. If you have like some data access code that's reaching out to a web service and it's only using .NET standard libraries, you can have that live in a separate shared project that the Android project and the iOS project reference. And so you can get a little bit of code sharing that way. Things like data models and also like any client-side business logic, all that kind of code can be shared. But the majority of code in a mobile app is going to be referencing the UI in some way. It's going to be handling tap events. It's going to be adding elements to the page dynamically and piping data into all that stuff. And you still have to write those completely separate. So Xamarin Forms adds an abstraction over the UI between both of those platforms. And that abstraction uses XAML, which if you've ever done any Windows desktop app development in UWP or WPF, you are probably already familiar with XAML. I'll touch on some very basics of tonight. You got a question?
No, I'm finger spelling. Sorry.
Okay, no, you're fine. And sorry, train of thought derailed there for a second. No, you're fine. So if you've ever done any Windows desktop app development, you're probably familiar with XAML. You use this same, it's essentially a markup language. It looks a lot like XML. And you use that to define your UI. And what happens is when you write some XAML code and your code all gets compiled and ends up running on an iOS device, then there's already a layer that Xamarin provides that takes that XAML code and translates it into native UI. So for instance, there's a label component in Xamarin Forms for adding a piece of text into a view. That label, when it's running on iOS, it is going to use the Xamarin iOS wrappers around the iOS SDK to create an instance of what's called a UI label. The UI label is the class in iOS that is a label. And it's going to create an instance of that class. It's going to copy all the properties from your Xamarin Forms label to the UI label and add it into the page. And then on Android, it's going to do the same thing, but for the Android version of that view. So it's going to create, I'm pretty sure it's called a text view, and that's the name of the class that Android uses for adding a piece of text to the page, and it's going to do that same process. So what that means is that a Xamarin Forms application is technically a native application. You're looking at native UI when you're looking at a Xamarin Forms app. You're not looking at a web view that you would be with like something like Cordova. You're not using web technologies anywhere in this stack. You're building a native app, just with some abstractions over a lot of the APIs to allow you to write once and run anywhere. There's definitely some limitations when it comes to there. There's some components that don't exist in Xamarin Forms. For instance, if you want to play a video in a view, there is no Xamarin Forms video element to just start playing a video. And in cases like that, there is a special section of the framework that they call custom renderers, where you can write the code on each individual platform to use the native APIs to add native views that Xamarin doesn't have on its own. That's a little bit more of an advanced topic and not one that I plan on touching on tonight, but it's definitely something to keep aware of. If the Xamarin Forms API, abstraction over the UI doesn't provide the elements that you need to build your UI, you can build them yourself technically, or pull in a library that does it for you. Okay. I think that's probably it for description and stuff. We can, from there, I think we can jump into the demo. So, one thing to keep in mind when you're doing Xamarin Forms development, if you want to deploy to an iOS device, you have to have a Mac OS device. Apple only releases their developer tools to run on a Mac. And so you can't ever use Windows to build and deploy an iOS application. There is one exception though. I'm not sure what the name of the tool is, but Microsoft has some tool you can install on a Mac that lives on your same network, and your Windows version of Visual Studio can connect to that Mac, run the builds on the Mac, and deploy to an iOS device from there. But basically a Mac OS device has to be in the mix somewhere in order to do any iOS development. So that's why I am actually using a Mac tonight. And to get started, building a Xamarin Forms app, you basically just start, if you're on a Mac, you install the Visual Studio for Mac app, essentially. And I'm going to walk through just kind of some of the basic setup steps on creating a brand new Xamarin Forms app. So I'm opening Visual Studio for Mac, clicking New. I'm going to go here to this multi-platform section and go under Apps. Sorry if this is hard to see. It doesn't let me zoom in. I'm going to create a blank Forms app. I'll talk for a second about some of these other templates here. So there's blank Forms app, master detail Forms app, tabbed Forms app, and shell Forms app. Blank Forms is one we're going to use for tonight, but master detail, it's a little bit of a weird name considering what it actually does, but essentially when you start with this template, it gives you an app with a navigation bar and a sidebar with the ability to tap on the items in the sidebar and navigate to different pages that way. So that's what that template starts with. The tabbed Forms app starts with a series of tabs at the bottom of the UI where you can tap on those tabs and that'll navigate you to different pages. And then shells is a little bit of a combination between the two. It's something that was released in the latest version of Xamarin Forms that allows, it's a whole new API essentially for declaring what your navigation should look like in a Xamarin Forms app. And it also provides some really awesome utilities for navigating between views in a Xamarin Forms app. It lets you essentially create URL-looking type things to navigate between different views, which is something that's not available in Xamarin Forms. But we'll look at some navigation examples in a second. So I'm going to select blank Forms app, and I give it a name. It doesn't matter too much on what it is. It's also going to ask for an organization identifier. If you've ever built any kind of native apps, this is an identifier that comes with, that you have to give to uniquely identify your app in things like the App Store or the Google Play Store. And it asks what platforms we're trying to target. If I was on a Windows device and was using Visual Studio for Windows, I'm pretty sure Windows there would be a UWP option here. But since I'm on a Mac, I can't do any Windows development. And then it's asking, it has a couple options here under shared code. And so what this is going to generate at the end of the day is a new Visual Studio solution with 3 projects in it. It's going to have a shared project that has all of our UI code, and really like 99% of our code is going to live in there. And then it's also going to create a Xamarin Android project and a Xamarin iOS project. And the Xamarin Android and Xamarin iOS project essentially just load kind of the base app class from the shared project and instantiate it and pass it back to Xamarin Forms. And what this option is asking is the format we want that shared code project to be in. And there's two options there. There's a .NET Standard project, or there's a shared library project. And the main difference is that a .NET Standard project, when you compile your code, that project will become its own assembly, and that assembly would then get referenced into the other projects and pulled in that way. With a shared library, the code itself gets copied to the project that's doing the compiling. So that means when you're compiling for Android, it'll copy the entire project to the Android project and do the compile there. And that means that you can use compiler directives to conditionally write code depending on which platform you're in. And so it's one way to reference native APIs, because normally you don't have access to that in the Xamarin Forms shared project. But with this shared library approach, you can. For the most part, there's usually better ways of dealing with interacting with native code than doing the shared library project. Those compiler directives can really kind of clutter up some code and make it hard to read. So for the most part, I stick with the .NET Standard project. Go ahead and click next, and then the rest of this is a pretty standard Visual Studio project creation screen. It asks for the project name, solution name, where it wants to live on the computer, all that kind of stuff. Now, I can't stand Visual Studio for Mac. It's a pretty garbage editor in my opinion. So I'm going to be using Writer, which is the JetBrains .NET IDE. And it runs on Mac and Windows. And it doesn't have all the tools that Visual Studio for Mac has. In some instances, you have to open Visual Studio for Mac to run something that just isn't available in Writer. But for the most part, and for the purposes of this demo, I think we'll get along just fine. So right here, we're looking at Writer with the base project already created. So all I did was just create a brand new project and started from here. So right here is our solution up at the top. And then here's our three projects, just like I talked about. There's the Breaking Bad Android, the Breaking Bad iOS, and Breaking Bad. Also, forgot to mention this. When going through, ideas for a demo, there was a new Breaking Bad movie that came out last month. And so I looked up some APIs, and turns out there's a Breaking Bad API. Yes?
A question about Writer that I had a moment
Sure,
ago.
yeah.
You said that it has fewer tools than Visual Studio. Does that imply that it is less resource heavy on the machine?
I don't know. I haven't really done a lot of testing there to see if it is. It's definitely still just as resource intensive, I would say. On slower computers, you'll definitely notice some stuff, and I'll go look at Activity Monitor and see it's using a couple of gigs of RAM sometimes when I'm in a big project. So I don't think it's less resource intensive. It still has to do most of the things that Visual Studio has. The main instances where you run into that are, for instance, when you're looking at some XAML code, normally there are viewers available for that XAML code to get kind of a drag and drop UI. That is not available in Writer. That's only in Visual Studio. So those are the kind of tools that I'm saying aren't available in Writer. But as far as resources go, they're, I would say, about the same.
Oh, well. As someone with a slower laptop, I thought, oh.
Yeah, that might be nicer. Definitely give it a try. It might help. You never know. Okay, but anyways, what I'm going to be doing is using this Breaking Bad API to build a really simple app that pulls in some data from this API. And also, Breaking Bad is one of my favorite TV shows ever. So that's why it says Breaking Bad everywhere. So I'm going to first start by opening up the shared project here. And what we see here is there's kind of two main files here. There's this app.xaml and main page.xaml. And those have files nested underneath them because Writer by default, and I think Visual Studio does this too, when there's a code behind file for a XAML file, it adds a nice little dropdown. But if I open up the appxaml.cs, in this file, we're inheriting from this application class that's provided by Xamarin Forms. And this right here is kind of the entry point into our Xamarin Forms application. Also in here, there's some overrides for some useful lifecycle methods. There's plenty of instances where you might want to do something depending on how the app is being started. This on sleep, like when the user exits the app or when the user opens the app from just going back to the home screen. These are some lifecycle methods for all that kind of stuff. Now, I also want to show kind of how this is referenced back into those native projects. So if I jump down to this Breaking Bad Android project, this right here is mostly what you would be looking at if you went to Android Studio and created a brand new project, except for instead of mainActivity.cs, it would be mainActivity.java or mainActivity.kt for Kotlin. But if I open this up, if you also compared this against the default class that gets created in Android Studio, you'd see this there's a lot of similarities. It's kind of just the language that's the difference here. So we're creating a new activity class. It's inheriting from this special Xamarin Forms activity. And then in this onCreate method, which is the Android version of your entry point, it's doing a little bit of initialization, but then right here at the end, it's running load application and passing in an instance of our Xamarin Forms app from the shared code. And then on the same side, if we open up the iOS version, we have this app delegate.c#. And this is the exact same thing, but for iOS. And in here we have this finish launching method on our app delegate class, where we do essentially the same thing. We say load application and pass in our Xamarin Forms app. But once again, in these projects, we have access to the entire native iOS SDK and the Android SDK on the other side. So if you need to do something in the native land, right, that Xamarin Forms doesn't provide, you have the ability to do that in this project here. So back in app.xaml.cs, there's a main page property that we're setting to a new instance of this main page class. And this main page class is essentially just a Xamarin page. If I open this up, there's a XAML file and once again a code behind file for it. And there's a little bit of some XAML markup here. And I'll break down XAML some more in just a minute. But if we wanted to show a different page here, we would just pass in a different class to that main page. And if I go ahead and, let's go ahead and run this and just see what it looks like. So I'm gonna go to run, gonna select iOS. And this will just launch the iOS simulator, which is, if you have a Mac, you have access to this simulator at all times to just test something really quick in iOS. And this might take just a second to launch. Okay.
Oh my.
Why is there two? Well. Okay, so you can see here, it launched the app with a little hello world basically, and that's the text from this label right here. And then there's also some options on here to center it vertically and horizontally.
You have hot reload?
There is hot reload. That's a tool that's only available in Visual Studio though. So in Writer, you can use the hot reload, but there is some experimental uses of it in Visual Studio. I don't think it's ready for prime time yet, but I did mess around with it the other day, and you could essentially, I don't remember if it was a keyboard shortcut, if it just did it on save, but it would hot reload. It would only hot reload though when you are editing pure XAML. If you ever go into a code behind file and hook up an event listener, you're gonna have to relaunch the app entirely. So to get started building out the demo, the first thing I want to do is add a navigation bar up here at the top. Don't know why that one's all zoomed in. We'll launch that again in a second. And so how to add that navigation bar is if I go back into app.xaml.cs where I added the main page, I'm going to, instead of creating main page directly, I'm going to add a new navigation page and pass in my main page class. If I go back up to run, I'm going to reload it. This will take just a second. We're going to see this just take a second for a few times. Now it's kind of hard to see. There is technically a navigation page here. The one thing that I'll need to change is whatever page gets passed into the navigation page needs to define a title. So I'll come in here and there's technically a public property that I can set called title in my code behind file. I'll set that equal to main page. And then we will reload. And now we should see that just the text main page shows up at the top. Okay, there we go. So there's a couple customizations that we can make to this. So as an initializer, we can set a couple public properties on navigation page here. So that would be bar background color. I'm going to set that equal to color.fromHex. And I have a great color already picked out for this in my notes. So I'll copy that color.
While you're figuring out that color there,
Yeah.
which you've already figured out, how many different options do you have to pass in main page into? Because it seems like to me that if you want any sort of navigation, you have to have that nav bar.
Yes, essentially. I don't remember all the ways to do navigation, but the primary one is to use a navigation page, right? And one thing to note is that whenever you use this navigation class, it will set a public property on the page you pass in called navigation. And that public property is a class that allows you to perform navigations back and forth. Now, I think it's actually possible to create a navigation page without actually displaying it, so you still have access to the ability to switch between pages and stuff like that.
But is it just navigation, that's the only option? Like if I wanted to list a page, would that be a different thing that I pass the main page into?
No, I think navigation is really the only option here. We'll see in a second how to do like a list view. The list view itself would actually live inside the page you're creating.
Okay, so that'd be within main page.
Yes, in main page we'll create a list. We're going to do that in just a few minutes. Now I'm also going to set our text color equal to color.white, and we'll reload one more time. And the main reason I'm doing this is to also kind of show off the advantage of having these two projects here, which is something that like when you're using tools like Cordova, you just don't quite have access to. Or if you do, it's through some weird, custom option. So right here, this changed the color of it, but it didn't automatically change the color of the status bar icons. This is something, kind of, a limitation you might run into with Xamarin Forms is it doesn't quite do the same thing to some native controls that you might assume it does. And on Android, if I launched this right now, we would see our navigation page, but this status bar up here would actually just be a completely different color. I think it's like the default blue or something like that. And so what's really cool about Xamarin Forms is if we break down into this iOS project, there's this info.plist file. And this is a file that gets created when you create just a native iOS project. And it's essentially a XML file containing configuration options for your app. So in my notes here, let me copy this bit of XML. And this is very specific to iOS. So if I come and paste this bit of XML in, and then I reload, you see now the text is that white up at the top. And so because we have access to the native projects, any native customization that we want to do, like changing those status bar colors, we can totally do. So just wanted to point that. And also to do the same thing in the Breaking Bad Android one, I think it's under resources, values, styles.xml, and if you change this color primary dark, that changes the status bar color of your app. But once again, you just have total customization because you have access to the native projects here. So jumping back to the shared code project, it's next on the list here. So next, let's walk through just a little bit of some XAML customization. So I'm going to start by creating a different page to put this kind of stuff in. So the overall app is going to be pretty simple. We're going to have a list view that contains all the characters from Breaking Bad, and also the spin-off series, Better Call Saul. It's going to just contain a list of all of them, and whenever you tap on one, it'll take you to a detail page where it shows an image and a little bit more details about them. So I'm going to create a new folder in here called Views, and I'm going to create a new Xamarin Form template called Character Detail Page. And what that did automatically for me is generate the XAML CS and the XAML. And for some reason, this template started doing something weird where it doesn't fill in this little bit of code. I'll explain more about what this does in just a second. Character detail page. Okay. So if you've never ran into XAML before, I want to give like a quick crash course on essentially what it does. And this is a very kind of oversimplification of what XAML actually is. So at the end of the day, I like to think of XAML, I know it's a little bit more complicated than this, but it's essentially just a declarative way of creating instances of classes. So what we're looking at with this hierarchical XML structure is this content page element here is an actual class. There is a content page class provided by Xamarin Forms. And when we're adding it into this page like this, we're essentially creating an instance of it. And then any properties that we set, so like on this label, right here we're setting the label's text property. This is setting the value of a public property on that class. So the label class has a public property called text, and we're setting it equal to this string value right here. And same for these horizontal and vertical options here. Those are just public properties on the class. And then the other thing to keep in mind is that kind of the other part about XML that tripped me up for a while was there are some properties that expect more XAML as the value. So, for instance, we're going to talk about this list view setup in a minute. It has a property called item template. And that property is essentially what each row in this list should look like when it's looping through all of the contents. And that list view property needs it to be more XAML code. And there is no way in XAML, at least not that I know of, to just do that as an attribute, to create that property as an attribute in XML and pass in some XAML. And so that's what this right here is. It's called property element syntax, but whenever a element needs more XAML as its value, you use the name of the element again, dot, and then the property name, and use the same for the closing tag here. So what this is doing is setting the content property of this content page element equal to this stack layout. Hopefully that makes sense there. Something else to keep in mind is that the template does is a little bit more explicit than it needs to be. By default, whenever you are just embedding some XAML into, as a child of the element, it defaults to setting the content property, so I can actually just get rid of content here, and we're looking at the exact same piece of code. And I'm pretty sure I could even do the same with stack layout. I could say stack layout.content. Oh no, it's children for stack layout. But this is essentially the same thing. So every element has a default property that when you pass in children like this, it sets that property. But we don't need to do that. It's kind of it's just a little bit more verbose in doing it that way. Okay, so that's kind of a quick crash course on XAML. Now let's kind of build out some of the basics of this character detail page. So the first thing we need to do is I'm going to create a model that represents a character. So I'm going to go into Breaking Bad. I'm going to add a new class called model character. And I'm going to go quickly copy some code for that. It's pretty straightforward. I also need to install a library. The data comes in over a JSON REST API, and so I'm converting in here some of the properties from the API to a C# style name of the property. And to do that, I need to pull in the Newtonsoft library. So manage NuGet packages, Newtonsoft.json. So I'll quickly add that project, and we should see that the red disappears from here. Okay, so here's our model. Now back in character detail page, let me pull in some dummy data to instantiate one of these models. I'm not setting every single property on it, just a couple to demo. So I'm going to say var character equals, and we'll import the references. So I'm just creating kind of a blank character. Walter White, obviously, best character in the movie, or in the show, and setting some public properties on there so we can use that. So the first thing I'm going to do is let's change this label to, instead of displaying some text right here, let's set it to display his name. And the data itself lives in our C#. We could just come in here and set text equal to Walter White, but we want it to come from our character model. So I'm going to come back in here, and I need access to that label to be able to set some of its content, set its text property essentially. And how we do that is I use this xName property, and I'll just call it character name. Now, what this does is creates a private field in my class with this name that is typed as this label. And after we run, I think it's this initialize component function, we will have access to it. So I should be able to say at this point, character name, which is automatically auto-completing that for me, dot text, because every label has a text property, and we'll set that equal to character.name. And then I'll save, go to run, and reload. We should see that this text now just becomes a Walter White. And, oh, hey, that didn't work. Oh, this makes sense. So back in our app.xaml, we're still using that main page instead of the character detail page. So I'm just going to instantiate character detail page here. And run. Okay. And you need it now? There we go. Now now it says Walter White. Awesome. So we could do that for every piece of data in here, but that definitely gets a little bit annoying. That kind of code to write is very repetitive, to just basically take elements from the UI and set their values equal to something from your incoming data. And so Xamarin Forms provides a much better syntax for handling this kind of stuff. So every Xamarin, totally skipped over something earlier that I meant to cover. Whenever we are looking at a code behind file, you'll notice that the class that's defined here is a partial class. And that's because the rest of the definition for this class is in the XAML code. So that means that what you're looking at when you're looking at this and the code behind is essentially the same class. You can think of it as the same class. And what that means is whenever we create, whenever we're working with a XAML here, this root element here needs to be the same element that we inherit from back in our code behind file. So just keep that in mind. That's something that tripped me up plenty of times while working through this. So one thing that we can do is every element in Xamarin has a property called binding context. And so really, and I'll demo kind of what this exactly does, but I'm basically going to say binding context equals character. And I'm going to get rid of this part right here. And then I'm going to go into the character detail page, and I'm going to get rid of the name here as well. And I'm going to say text is equal to, and I'm going to use this curly brace syntax. I'm going to say binding name. And so what this does is whenever you set the binding context on an element back in your code behind file, you can use this syntax here. It's called markup extension syntax. And essentially what it's doing is it's looking at the binding context that we set, which is a character object, and it's taking the name property from that character object and binding its value to the text property of the label here. Now, something to note is that we didn't set the binding context of the label, we set the binding context of this content page, technically. And that's how that works is whenever you try and use this binding syntax right here, Xamarin essentially sees if this element has a binding context, and if it doesn't, it goes to its parent element and looks for a binding context. And if it doesn't find one, it goes to its parent element. So we're setting the binding context on the content page here, but we can use it farther down in the tree. And so I'll also take the title property that we had used earlier, and I'll use some binding there as well. So I'll say binding, let's make this name, and we'll set this equal to nickname. And you'll see these are pulling from the same object here. And then also let's go get rid of, okay, we already got rid of the title. Or we never created it in this one. So we'll go to run iOS. And we should see their name shows up in the navigation up here at the top, and their nickname shows up centered in the bottom. And I did that.
Portray instead of nickname.
Oh, it's lowercase nickname. Pretty sure that's what's up there. Also, it doesn't throw an error when you do that either, so you don't have to double check everything. It can get annoying. It means that it's sometimes harder to find the bug, but at least your users don't see an error when you misspell something.
You can set it as a property.
It's not a field.
What's that?
Using portrayed.
There's no data for nickname.
There's no. Did I not set that?
No.
Oh, you're right. Okay, we'll use portrayed then. That makes more sense. Portrayed, which is supposed to represent the. Is that how I spelled that? I'll just copy it in case I didn't spell it that way. I don't trust myself that much. Okay.
Does anyone trust themselves that much?
Yeah, definitely not, especially not when giving a demo. Okay, so now this reloads. Yep, we'll see Bryan Cranston there is Walter White. So that's kind of how the binding works. Next, let's jump into. So if we wanted to let this character detail page work for more than one character, instead of just this one that we've hard coded, the basic way to do that would be essentially just to accept it as we could either make a public property or we could simply just accept it in the constructor here. So I'll say character equals character. Let's create a read-only. I don't think this needs to be read-only. And we'll get rid of this manual creation. We still want to continue to set binding context to be to be our character here. I guess we really don't even need that, honestly. And now our app XAML CS is complaining. So instead of doing this, we're actually going to take a step back instead of trying to finish this, and let's build out the listing page instead. So I'm going to go to Views, Add, Xamarin Form, Character List Page. And once again, it didn't connect the class. That's another thing to note here is that this class property on the top level Xamarin Forms element needs to point back to the original class, or the class that it's supposed to be connected to. So we'll copy that, and we have to give it the full namespace to that as well. Not sure why that template isn't working. Character list page. Okay, and we want this to be a list view, so we're gonna mess around with a list view then. So I'm gonna use list view here, and once again, I remember mentioning earlier that we had to, when I was going over the element property syntax, list views need a template for each individual item in the list. So I'm going to say list view dot item template, and item template expects to be what they call a data template. And this probably seems a little bit verbose to have so much of this here, but the reason that this data template here is in the first place is because you can use what are called data template selectors, which is a little class that can return different data templates depending on what the data is. So when you're scrolling through a list, if you need the items in each list to display differently depending on the data, you can use those data template selectors to give back different templates depending on what the item is. So that's kind of why you have to start with a data template here. And then inside data template, we create what's called a cell. When you're interacting with the list view, each item in the row becomes a cell. And there's a built-in cell already called text cell. So text cell has two properties, text and detail. And basically that's just like a little bit of headline text and a subtitle right underneath it. So I'm going to set text equal to binding, and when we have our data, and we're going to be interacting with character models in a bit, we're going to use name here. And then for the detail, we'll say binding nickname, and we'll actually have that data later. Now, what's also interesting here is we haven't really set the binding context anywhere, but we're still going to be using this binding syntax here. And essentially, on every iteration of the list here, the list view is going to automatically set the binding context for us to be whatever item in the list we're currently iterating over. So that's why we're going to automatically be able to do this. Now, the other property that a list view has to have is a list of items. They call that property item source. And we could define it in line here as another element property. So I could say item source, items source. And I could there's a way in XML to just create like an array of strings or something like that. But we want this data to come from like a web service. So I'm going to go back into the code behind, and we're going to start going through fetching some data. The first thing I want to show off really quick is registering a service. I love using the IOC container in .NET, so I'm going to register an HTTP client as a service so I don't have to worry about instantiating one. So I'll say, back in my app class, I can register services here. So I'll say dependency service dot register, and I'll pass in an HTTP client. And then anywhere I want, so in my character list component here, I'll just go ahead and pull that out. So I'll say HTTP client equals dependency service dot get an instance of HTTP client for me, and it'll automatically manage that for me. You can't use constructor injection because most of the time you're actually manually instantiating your view classes when you're navigating between views, and also like when you're setting the main page, so that you can't use constructor injection to handle that kind of stuff. You have to use this dependency service class. But this will give us an instance of HTTP client. And now I'm going to use, HTTP client has a whole lot of async methods on it, and I can't use async await inside of constructor. And so Xamarin, whenever you're looking at a view, provides a lifecycle hook for when that view is initially being shown. And it's just a method you override called onAppearing. And it's a void method. We can make it async void. So we can use the async keyword if we'd rather. And so in here, we're going to make a request to a URL. Now, one thing I did run into with this Breaking Bad API is it's a little bit of a stickler when it comes to rate limiting. And so to avoid any issues, I took the data from the main view and just uploaded it to a file in GitHub. And so we'll just pull the data from that instead, but we could replace it with the official Breaking Bad API if we wanted to. So back in my notes, let me grab that URL, which we'll open it really quick so we can look at some of this data looks like. It's an array of objects, very simple, character ID, name, birthday, which seasons this character appeared in, whether or not they were in Better Call Saul, which is the spin-off series, or if they were in Breaking Bad. All the basic data we need when it comes to Breaking Bad information. So I'm going to take this URL, put it into my code here. Whoops. Oh, I hope I copied it. Okay, I did. And so I couldn't tell if there was a semicolon there. Yeah, there is. And then I'll say var request equals await http client.get async URL. And then I'll say var response equals await request.content.read as string async. And then the last thing I'm going to do is get all the characters in. I'm going to convert this string of JSON using the Newtonsoft library and convert it into a list of characters that we can use. So character, and then I'll pass in response. And that'll automatically handle everything for us, basically. And so at this point, if I ran our code, well, not if I ran our code, because the last step we need to do is update which page we're showing in our navigation page. So I'll say new character list page. So now if I ran my code, which let's just double check and make sure that this works. If I new characters and add a breakpoint here, we can also, I also kind of want to show that we can do normal debugging stuff. So I'll go ahead and stop the default one and we'll debug. And as soon as it opens, if I didn't write any bad code, which is likely, we should see right here, if I hover over characters, boom, we have a list of characters coming in. If I open the first one, all of our data is being parsed in correctly, the char ID, the Better Call Saul appearance, all that stuff. Cool, so our data stuff is working. Now we just need to, let's go ahead and stop debugging. Now we just need to tell the list view about all this data that we just brought in. So I'm going to go back to character list page, and I'm going to add a name to our list view so that we can reference it back in our code behind. So I'm going to say, just give the name list view, and then back in here, I'm going to say list view dot items source is equal to characters. As long as the object that you're setting it to is an enumerable object, then it should work. And we'll go ahead and save here. Run iOS default. Boom! So there's our list view full of all of the characters that is available in this data with their nickname displayed right underneath them. One last little thing we could do is we could add a title here, just a hard-coded one. Say title equals Breaking Bad characters. Okay, and you can also see that the binding is working here, right? Because the binding context of our data template is, the objects as they're being iterated over. Okay. Now something else, if you've ever done any native Android or iOS development, you'll probably have run into, when working with lists, if you're used to doing things on the web, and you're using something like Razor Pages or something like that, you're pretty used to making a for loop and iterating over some collection and just spitting out HTML for each element in that collection. Normally, that kind of, putting everything in the page at once is frowned upon in native development. Most of the time, you have to basically create a template for every item in the list, and just tell the kind of list view itself what all of your data looks like, and it'll manage rendering everything. And the reason behind that is when you're in a native view, as items are scrolling off screen, the object that represents that UI item or that cell is being reused when the next item comes into view, so that the platform doesn't have to instantiate a whole bunch of objects for you. And what's awesome is the list view automatically does that. So as you're scrolling in that list, it's not sitting there creating new objects for you consistently in there. It's reusing the same objects and just setting their properties to be the next piece of data in your collection. So that's awesome that Xamarin Forms is already handling kind of some of that performance stuff for you. To do it natively is definitely a little bit more complicated. You have to manually do some more things to make that kind of stuff happen. Okay. So now we have our list view. Now let's do some basic navigation. What happened? How do we hook up a tap event on one of these items to navigate to our detail page? And so in our code behind, I'm going to create an event handler function. So I'll say private void list view on selected. And the arguments that come in are object sender. This is a pretty standard definition for an event handler. And then there is a selected item changed event args class. That will be our event itself. And if we go look at the source code for this class really quick, we'll see in here there's a selected item property, but that selected item is just an object. So when we want to, whoops, let's just pull, okay. Let's pull it back up this way. So if we want to actually grab the item off of this event object here, we're essentially going to have to do a cast. So to get the character that they selected, I'm going to cast it to a character, e.selected item. And it will be the actual class. It won't be like an ID in the list, it'll be the class itself. But we do have to do the cast here because by default it's just an object. And so at this point, we're ready to do some navigation. And remember, I said back in when we were looking at app.xaml.cs, when you instantiate a navigation page here, it sets a public property on whatever page you pass in called navigation. And that navigation property you can use to actually navigate between pages. So I will say navigation.push async, and I'll pass in a new character detail page and pass in the selected character. Now this is an async method, so I might as well just say make this method async, and I'll await this, just in case I needed to do something afterwards. And also, I wanted to call out the push here. So in mobile applications, navigation is entirely based on a stack. So as you navigate between pages, you will add that page to the stack of pages. And then as a user hits either the hardware back button on their device or the back button up in the navigation, it pops pages off. And so this navigation API works, it's listed that same way. Navigation itself is essentially a stack that you can add pages onto and remove pages from. So the last thing we need to do is hook up this event listener to an actual item selected event. So I'm going to jump back over to character list page, and on the list view itself, there's I think it's item selected. Yeah, item selected, and we will just pass in a reference to our method there. So we're not calling our method here, we're passing in a reference to our method. So this method will get called with those arguments passed in whenever an item is selected. And so at this point, if we've done everything right here, we're passing in character, sending the binding context to that. We should be able to build or run. And now whenever we tap on one of these list items, it should automatically take us over to the detail page for it. So I'll go ahead and tap on Walter White. Boom, we see that data bound in correctly. If I tap on Jesse Pinkman, we see that data bound in correctly. All right, last big thing that I want to cover really quick is just some UI customization. So I have some UI that I put together a few minutes ago for some a better detail view here. So I'm going to get rid of the label, and now I'll kind of just talk about like some real basic layout stuff. We're not going to go super hard into doing layout in Xamarin Forms because it is kind of its own thing. It's different from most things, most ways of doing layout, like on the web or even natively. But one element you can use that helps a lot in layout is a stack layout. So by default, a stack layout can have as many children as it needs, and it just stacks them on top of each other with a bit of default spacing in between each element. Now you can come in here, and if you don't want that spacing, you can set it equal to 0, and it won't have the spacing between the elements. Another useful feature of stack layout is you can set orientation equal to horizontal, and it'll lay the elements out left to right instead of vertically. And the other nice thing that you can do with a stack layout is you can nest them. So you can build most layouts, and most of the layouts I built in Xamarin Forms were just simply stack layouts, kind of nested together. There's quite a few other layout options. There's a grid layout option where you specify a list of columns and you specify a list of rows, and then you add your content for the grid and you specify which the row and column for each of those items. And you can also, that's another way to like overlay items if you needed to as well. If you put both items in a grid and give them the same row and column, they'll just get put one on top of the other. And whichever one comes later in your markup gets put on top. But for the most part, we're just going to use stack layout. And for this UI, the first thing I'm going to do is use an image component here. And images have a source attribute. We're going to set source equal to binding. The property is ing. And then another thing that images have is an aspect property. And this aspect controls how it crops the image. Aspect, if you just use fill, it will stretch the image to fit the dimensions that you set. If you use aspect fill, it crops the image in without messing with the aspect ratio of the image at all. And then aspect fit makes sure that the entire image fits even if there's some white space around it. So we're going to use aspect fill here. And then the last one I was going to do is just give it a specific height. And when you're setting height on elements in Xamarin Forms layout, normally you use I can't do that. Normally you use height request instead of height, and it will try to give it whatever height you specify. And if it fails, it'll do a little bit less than that. So we'll set the height of that to 500. And then I want some text underneath the image. And this image I want to go full width across the screen here, so from side to side, but when it comes to the text, I want a little bit of spacing on the side so it doesn't scrunch up against the edge of the screen. And so one way to do that is just to nest all the text things I'm about to do inside of another stack layout and give that stack layout some padding. I'm trying to remember the exact order of padding. You can set the top, left, right, and bottom padding, and I think it starts with left. So
Left top.
yeah, I'm pretty sure is that the same as
Right
CSS?
bottom.
Yeah, I think that's the same as CSS. And so that'll give me 10 pixels of padding basically on the left side and the right side.
Hopefully.
Yes, we'll see. And then I'll add a label here, and that label will bind the, what are some pieces of data that I had in there? We already bound their name.
You can try that nickname.
Yeah, we can try nickname. Why not? Let's try nickname. So we'll bind in, oops, detail page. We'll bind in the nickname, so we'll say text. We'll say, this is a kind of another example I wanted to go over here. It'd be awesome to have kind of a label like the property name, a colon, and then the actual value here. So essentially doing some kind of string manipulation before we bind the property in. So I'll say binding nickname, and then in here I can add a comma and say string format. And in here I can specify a formatted string. So I'll say nickname, colon, and then parentheses 0, and then the nickname value will get passed in right there.
Missing an E on nickname.
Oh, yep, thank you. I had some example code for the properties that I was going to display. Let me see what those were again. Category, occupation. Oh, yeah, the show that it's from. Yeah, let's do that. So nickname, that's a good one. We'll have the, like an appears on to say which show they're from, because this has characters from Breaking Bad and Better Call Saul. And we'll say, and they call that property category. So category. Then we'll also do the occupation. Now, occupation is a little bit of a weird one. If I go look at character, occupation is a list of strings here. And I can't bind a list of strings as a value to text because text expects strings and only strings. So I'll need to do a little bit of conversion for that one in my code behind. And to do that, I'm actually just going to come back to this. I'm going to say name is occupation. And so I'll set the text value manually after I join all the strings together from the array into a single value. And then the last one was the portrayed by. So I'll say text equals binding portrayed. Do string format again here.
Category have the same problem as occupation if it's a list of categories.
So actually, if we go look at here, category is a string, and they just like comma separate them. It should have probably been a list, but whoever designed this API didn't really think about that. And I imagine they like didn't. It was made before Better Call Saul even came out, and so it was just like one, or maybe it was a property they added later. If we come back in though, portrayed, played by, and then 0. And so now let's go write the code for occupation here. So after initialize component and after binding context, I will say occupation dot text is equal to a string where we say occupation, and in there we will use the static string dot join method. We'll just join them on commas or join them with commas, and then we'll pass in a character dot occupation. Okay, that all looks right to me. Let's go ahead and go to run, and we will reload here. Hopefully all this works. Has it already reloaded? It might have already reloaded. Let's see. And boom, awesome. So we have our image, goes all the way to the sides. They're all 500 pixels tall. And in here we can see all of our data is being bound in correctly. And if we go down to a random one, we can see image, occupation, all that kind of stuff. So that right there is the Breaking Bad app. The last kind of thing I want to touch on really quick, and I don't really have a demo of this part prepared, but this kind of logic right here, where you're taking your data model and needing to do some transformations on it, is normally frowned upon from doing in the code behind. Generally, when you're architecting a real Xamarin Forms app, you usually use what they call view models. And a view model is essentially a layer of indirection between your actual data and how it's displayed on the page. So it sits in between your model and the actual view. Yeah.
Is that because it may not be necessarily inherent VUE by chance? Or is that something else?
What's that? Sorry, I don't think I
Is that view like the normal word, or?
Oh, it's view like the normal word. Yep.
Okay.
Yep. Sorry, not view UE. Yep. No, not view UE.
Okay.
Good distinction there, though. But these view models are essentially classes that take in your model and then kind of provide a new public API for your views to actually use and pull all that data in. And you could have, a computed property essentially in your view model that did this bit of conversion for you, and so it doesn't need to live in here. And what's really awesome is those view models, because they aren't really tied to the UI in any way, and not really even tied to your model in any way, they're really easy to test. They can be tested independently of anything else in your system. The other thing that I'll mention with these view models is whenever you're binding data into properties, there are some elements, form controls, for instance, that can emit values back out, and you can set up view models to automatically listen for those changes, and then use that value again somewhere else in the UI. So you can get kind of a, typing into an input box, automatically updating text somewhere else in the app for you, which is really a great way to do apps. If you've done any modern front-end framework stuff like React or Vue.js, that kind of stuff you're using all the time to automatically update values throughout your UI. And so view models allow you to kind of have that same setup in Xamarin Forms. And it's how, if you're going to update any data based on user interaction, definitely look more into view models. But anyways.
So right now, though,
Mhm.
this only works on iPhone.
Oh yeah, let's go ahead and try running this on Android. So I will come down here to run. It's a very good point. Well, this will definitely take a second to start. The Android emulator is a true virtual machine running on my Mac here, with which the iOS simulator is not quite a full-blown VM. And so it usually is a lot faster to start up and iterate through. It's still not showing the updated thing. It's launched the emulator at this point. Now it needs to install the app. Okay, and our data should come in any second. Come on, where are you? There we go. We can see now It's now the UI doesn't look quite the same here because once again it's rendering native views underneath the hood here. Now as a quick styling change to get rid of this pink text here, let's just run over to character list page, and I'm pretty sure there's a text color property that I can set to make all of that black. Text color black. And now if I run, but we can also really quickly just make sure that yeah, navigation is working the same. We can see that it's loading in our data here. Come on. So yeah, we're still getting some of the same things. Oh, it's actually displaying everything, but something else to note, glad that I ran that on Android, is in our character detail page, by default the pages don't scroll if the data goes beyond the user's view. So one thing that I can do is just wrap everything in a scroll view component, which will add a scroll bar if it tries to go outside of the bounds of the viewport. I don't think that will really even come into play here, but just in case I'll relaunch it. Now you can also see the status bar didn't change. Once again, this is kind of a bit of native customization that we have to do. If I jump down into the Android version of the project here, well, let me grab the color, whatever the color was. Let's grab this hexadecimal value, and I'll go into the Android version of the project, resources, not layout, whoops, values, styles, and I will set this right here. Also, right here, this pink color, that was the color of that text. So right here, this is kind of some basic theming for your Android app as a whole, and it was just pulling default values from that, which we could override back in the Xamarin side of things. So let's run, and while that's loading, try loading some, yeah, there's not quite enough data in most of these. Maybe,
You might even have to go back into your template and add some more then.
yeah, we could, yeah, to demo that, definitely. Let's add let's just spit their birthday out on there. So we'll say views, character detail page, and we'll just add, say birthday, and we'll just say birthday right here. And let me make sure the property name is birthday. Now, this brings up kind of another detail is birthday. I'm not getting any IntelliSense on the properties here, based on for the binding, and that's just because this whole binding context thing is really dynamic. The fact that it goes up the hierarchy of views to try and get that. I know that there is some special syntax which I have never messed around with before. You can add up here to basically say what the binding context for this whole view is. That'll give you some auto completion there. Okay, now if I run Android default. You can also see it already updated to have the updated status bar because I relaunched it a second ago. And there we go. We have a little bit of scroll action happening here with that additional birthday property on there. So anyways, that's kind of the basics of Xamarin Forms. There's definitely a lot more to it, just in terms of like developing your UI. There's tons of stuff that I didn't touch on here. There's absolute layouts and relative layouts. The main one being like stack and grid and stuff like that. You can get a lot done with just those two. But are there any other questions? I can answer really quick. Go ahead, Fred.
Does the scroll view muck up the iOS?
It shouldn't. Go ahead and stop this. I don't think we'll see it do anything because the screen that's displaying for iOS is a lot bigger.
Just copy the same line multiple times.
Yeah, sure.
Just
Yeah.
change the image height. Just change the height of the
Try
image.
the image height,
Yeah, let's make this like 900. Which I'll show you it without it first. Where's simulator? So if I jump in here, this one has a scroll view, and it's allowing it to scroll even though that it doesn't need to. But if we come back,
Would that happen anyway without the scroll view on iOS?
no, we wouldn't be able to do this. This wouldn't happen without the scroll view.
So that would be one of those custom things you'd have to do on the iOS side to not make it do the scroll.
Not necessarily. You probably could basically just do some calculation to see if like your content is larger than the viewport and kind of like dynamically turn this on essentially. I think there's probably even a way to disable it.
If you turn it, is it auto
Yes, it should. Let's see.
rotating?
Device, or no, how do I do that? Rotate left. Yep. So we need to update our UI to work with the notch better. I think there is actually even like a function we can call where it'll automatically move some of this stuff over. I don't remember though. Rotate. Wow. Right. Oh yeah, we were trying out the much higher image. So I'll reload that. Yeah, so now it's really tall, but it's, yeah, the scroll view is still working on iOS, the same on Android. Where did that go? Right there. Okay, cool. Any other questions? Yeah.
What sort of methods might we call if we wanted to access the phone's hardware and make use of it?
Yes, that's a great question. So there's a few ways to do that. For the most part, Xamarin provides a package that I think is installed by default. If I look in here, packages. There's this Xamarin Essentials package, which allows you to call in, it's basically a wrapper around most of the APIs. So if you need camera access or location access, or the gallery access or calendar access, I'm pretty sure you can do all of those basic things using Xamarin Essentials. But there are definitely APIs that you won't have access to in using Essentials. It doesn't cover all the bases there.
Like,
I'm trying to think of some that aren't provided by default in there.
How about the native video card?
Oh, I highly doubt it.
Shaders to that.
I doubt that you would have direct access to that. Xamarin Essentials. So here's some of them: accelerometer, app information, barometer, battery information, clipboard, compass, connectivity, shake, display information, device information, email, file system helpers, flashlight, geocoding, geolocation. There's quite a few things in here, but I imagine there's got to be something missing from here. I mean, in some cases, if an API is like a feature is only available on one of the platforms, Xamarin Essentials might not have a wrapper around it for it. But once again, you can also jump down into the native projects and interact with those SDKs directly if you needed to. One thing that comes in really handy is that dependency service class. You can register dependencies in the native platforms that do different. You have an interface in your shared project for the functionality there, and then you register different implementations of that interface on each individual platform, and at runtime it'll just add the one you need. But in your shared code, you just build your write code based on the interface. Go ahead.
So if I wanted to write a shader for iOS, I would go directly into
Yeah, I guess theoretically you can. I'm not sure if like every single SDK is wrapped in C#. It's possible. Definitely not something I've explored even remotely, but theoretically maybe you could.
So if I wrote Objective-C, then this could compile that.
If you wrote Objective-C, this could compile that?
Yeah.
What do you mean by that?
So like if I wanted to do any low-level things,
Mhm.
I would have to write in Swift or Objective-C, right?
Right.
To access those lower-level libraries.
Potentially, once again, there's a C# wrapper around most of them. I'm not sure if they have covered every single one.
Right, we just covered that.
Yeah, but as far as using some Objective-C code in the Xamarin iOS project, you have to create what's called a C# binding for that code, which is not something I've really explored very heavily. But you kind of have to do your own work of wrapping that native, Objective-C code in C# in order to use it in Xamarin Forms. And the same goes for any third-party libraries. Now, I will say that NuGet is full of packages for Xamarin, but there are definitely SDKs that are written in Objective-C and Java that just aren't available in Xamarin Forms, or in Xamarin. And so it would kind of be up to you to try and wrap that in C#. Once again, I haven't really explored that bindings concept very much, but I know that it exists. And so in that way, yeah, if you want to go down the road of creating one of those custom bindings, then you might not be limited by anything at all.
It sounds like for a lot of the basic stuff, though, it's already just kind of laid out for you.
Right. If your app is, mostly just kind of like a viewer into a whole bunch of data, right? Then this is kind of a great solution for that. If your UI if you're fine with your UI looking pretty similar to native UI, and you're not trying to customize the heck out of it, then Xamarin Forms works really great here. Now, at the same time, I've also seen some really impressive stuff created, like UI-wise, built with Xamarin Forms, very custom-looking UIs. And so it's definitely powerful, but there's limitations, just like with any of the hybrid platforms out there.
But like if you're just wanting to do basic stuff like check what time it is and change the styles accordingly so that
Absolutely.
it's dark
Yep.
at night, for instance.
Yep, you can do all that kind of stuff in Xamarin Forms.
Or
It's definitely capable.
let the user pick a time, and when that time comes, flash the flashlight in addition to making noise.
Yes, yep, you can do all those kinds of things. Those are great app ideas. Can't wait to see them in the App Store with the Built with Xamarin Forms tagline. All right, any other questions? Go ahead.
Is MVVM still a thing, or do you see that much?
Yes, so when you deal with these view models, you're essentially following the MVVM pattern. It's highly encouraged when doing Xamarin Forms development. So it's just not something I wanted to get
Right.
too deep into with this demo, but yeah, definitely.
So is there still like, as far as like framework goes, because I remember back in my XAML days with WPF, there was MVVM Lite, and then when I got into, I wrote an app that was on what's now UWP, but
Sure.
back at the time it was Windows 8 and also iOS, and I used one called MVVM Cross.
I've heard of that
Is that
before.
still around? Okay, I'm just kinda curious.
I'm not really sure, and I'm not really sure how that applies to Xamarin Forms. I imagine it does, but it's the whole MVVM pattern is not like my forte. Like I'm definitely newer to Xamarin Forms
Yeah.
and the .NET ecosystem as a whole, honestly. And so I'm not totally sure if those are still widely used or not. I know that they are in Xamarin Android and Xamarin iOS development. Whenever I look up anything specific to those platforms, I usually come across some MVVM resources.
Right.
I would imagine it carries over to Xamarin Forms, but I couldn't tell you definitively.
Yeah, 'cause it seems like a lot of that is taken care of, because one thing like MVVM Cross did is it brought bindings
Oh, sure.
to
Yeah,
Xamarin iOS.
Right.
Before there was
right.
Xamarin Forms.
Yeah, definitely a lot of it is already
Now it's
kind of
Yeah,
provided.
now it's already done.
provided for you.
Yeah.
You write native Mac OS apps with Xamarin?
I don't think so. There is like a Xamarin Mac thing for framework, I guess, for building Mac apps using Xamarin, but there isn't, Mac is not currently like a deployment target for Xamarin Forms itself,
iOS is.
but iOS is.
What other?
It's really just the three that I mentioned earlier: Android, iOS, and UWP. Those are the three potential targets.
Somebody liked that. Whatever that was.
Right.
They're probably just gonna finish.
Yeah, I imagine.
Anything in particular that you have to take into account going to a tablet with iOS or Android?
I mean, that's the same with any kind of mobile app development, right? Yeah, you definitely want to test on those kind of devices, and there are you can conditionally render things and stuff like that, like you can natively, and so yeah, there's considerations just like with anything, just like doing responsive design on the web, you got to test and build for that. So definitely.
Well, actually, you raised a good point about that, because I know on iPads,
Mm-hmm.
some of the view components are actually laid out a bit differently
Mm.
and might render differently on the phone versus
Right.
the iPad. I wonder if.
Yeah, I'm not sure there either. I imagine if you look at the documentation for any specific Xamarin Forms component, it's going to tell you if it behaves differently on iPad and iOS devices or iPhone devices. But I haven't run into anything like that in particular. I also haven't done a lot of stuff trying to port it to iPad specifically. Yeah, go ahead.
I'm gonna sound kind of dumb for this one, I expect. Where do you grab the compiled solution to actually put it on an actual phone to test it?
So number one, you can use the tools directly provided by the IDE. So I can plug my phone in over a USB cable, and my phone will become a deployment target that I can push it to. And that works in Visual Studio, Writer, and in Visual Studio for Mac. Now, when you're getting ready to deploy to the store, you would do essentially a publish, like you would in a normal .NET project. And then in one of the output directories for Android, there will be the APK file. And then on iOS, you're normally to deploy anything to an iPhone, normally Xcode has to be involved in there somewhere. Xcode is the IDE for doing iOS apps. And it's also kind of the main way for getting access to the certificate stuff you have to deal with iOS. Now, I will say that Visual Studio for Mac does have the ability to sign in with your Apple ID and pull in some of those certificates if you have a pro Apple developer account. If you don't have one of those, you are stuck with opening opening it in Xcode somehow to get that kind of stuff set up. And also when you run a publish, I think most of the time you would have to use Visual Studio for Mac and its integrations with Xcode to actually sign and build your app ready for upload to the iOS store. Okay. All right. Well, that's it from me. Let me know. I'm going to be hanging out afterwards in the other room if anyone else has any more questions they want to talk about afterwards. Thank you very much.
Thank you.